pagi. Welcome to the guest lecture series 8 entitled Econometric Techniques for Data Analysis held by the Department of Economics, Faculty of Economics and Business, Universitas Erlangga. I am Yan Cherin from the Department of Economics will be your master ceremony today. First, on behalf of the Department of Economics Universitas Erlangga, I would like to sincerely express our appreciation to Prof. Rafayet Alam Ph.D. from University of Tennessee at Chattanooga for coming to our university. Welcome to the Department of Economics, Faculty Economic and Business Universitas Erlangga. We are pleased and honored to have you in this guest lecture today. And second, I wish to thank Bapak Rosanto Dwi Handoyo PhD as a head of the Department of Economics Universitas Erlangga for attending this guest lecture. I also wish to thank Bapak Awalin, Ilmiawan Awalin PhD as the moderator of the guest lecture today. Also, I would like to say thank you to all participants for joining this guest lecture. I hope this event will be insightful and beneficial for all the participants. Before that, their welcoming speech from our head department, Bapak Rosanto Dwi Handoyo PhD. For Bapak Rosanto, time and screen are yours.
Thank you very much, Erin. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, Professor Rafayet Alam, Indonesian time. Good morning, students, scholars, ladies and gentlemen. Thank you to everyone for joining this guest lecture today. First of all, it is such an honor for me to speak on behalf of Economic Department Universitas Erlangga, and I would like to warm welcome to our guest lecture to our campus, Faculty of Economic and Business, Erlangga University, Professor Rafayet Alam from University of Tennessee at Chattanooga, United States of America. I would like to express my appreciation to Professor Rafayet Alam from University of Tennessee for your time to share insight and knowledge about econometric technique for data analysis. Thank you very much for your time, Doctor. The audiences for today's lecturing are from students, especially those who took econometrics, development economics class, and also from the undergraduate, master degree, and doctoral degree student, and also from the lecturer of the Department of Economics and other faculty members as well. We wish that this collaboration can continue with other collaboration such as joint research, joint publication, and more academic lecturing in the future. As I said earlier, Professor Rafayet, for your information, as mentioned in my virtual background, our Department of Economics Erlangga now is in rank 251 of the world rank and rank of #1 in Indonesia based on subject of economics and econometrics. Our Erlangga University itself is now in rank in 450 in the global rank and #4 in Indonesia. For this reason, I have messages from our university that we expect our institution will improve to world-class university under 100 using QS ranking. And I hope Professor Rafayet can participate to vote us in the QS ranking survey next year. I would like to express my sincere gratitude to Dr. Marta for our contributing colleague to keep in touch with Professor Rafayet from University of Tennessee, and Dr. Awalin for being moderator, and also Pak Wahyu, Bu Haura, Bu Yesi, and others for arranging this guest lecture. This event would not be done without that hard work. Finally, I will hand it over again to our moderator, Dr. Awalin, to start the guest lecture. Once again, welcome and thank you very much for attending this event. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Bapak Rosanto, for your warm welcome speech. Okay, the main session of the lecture today will take over by the moderator. There will be a brief introduction of the guest speaker by the moderator, main presentation by the guest speaker, and discussion and Q&A session. But in addition, I would like to remind all of the participants, please turn off or mute your audio during the presentation. And if you turn your webcam on, please behave properly. Thank you. Next, I would like to introduce you all to our moderator today. Our moderator today is Bapak Ilmiawan Awalin, Ph.D. He is currently a lecturer in the Department of Economics, Universitas Erlangga, and with his expertise, he will be moderating our discussion and Q&A session. Without further ado, let's begin today's lecture by welcoming Bapak Awalin. So, Bapak, screen and time are yours.
Okay, thank you very much, Sherin. Right, so before the lecture, I would like to introduce our speaker today. Our speaker is Professor Rafayet Alam. He is currently an associate professor of economics at the University of Tennessee at Chattanooga, Tennessee, USA. So his education, he got his master in international and development economics from the ANU, Australian National University, Australia, 2012, and he's got his PhD in economics from Southern Illinois University, Carbondale, USA, in 2016. So I think you met Martha there in the ANU, right? Okay, so I myself was studied in Australia. I got my master in from the School of Economics, the University of Adelaide in South Australia, and I got my PhD in economics from the Sydney Uni. Right. So Professor Rafayet has many awards, including Outstanding Faculty Research Award from the Rollins College of Business UTC, UC Foundation Professorship from UTC, and there are still a lot more. And he is teaching many subjects, but mostly dealing with econometric, international economics, macroeconomics, and also principle of microeconomics. His research interest is in the applied econometrics and empirical macroeconomics. For the publication, I can see here there's lots of publication. I will not read them all, but Professor Rafayet has been publishing in many reputable journals and with some very interesting topics. Okay, so without further ado, I think we can start our lecture today. Professor Rafayet will give a lecture on econometric techniques of data analysis, and I think this is very relevant to our students, both who are taking the econometric class at the present time, and also for the students who are doing their research work at the present time. Okay, Professor Rafayet Alam, now I welcome you to give the lecture. The screen and time is yours.
Thank you, Dr. Elin. Have I pronounced it close? Almost, right? Okay.
Yeah, you can just call me Alin.
Alin, okay. Okay, thank you. And also thank you, Rosanto, and the presenter who introduced all to me and to the audience. So thanks for having me. It's a great opportunity for me. As you by this time probably you know that I have one of my good friends, Martha, in your institution. She was not only a very good student, she was also very helpful. I took a lot of helps from her during my study at ANU. She went back for PhD at ANU, I know, and completed PhD there. I didn't go for PhD there. I went to the US, but I mean, still she's a very good friend of mine. Now, let me get into the action. So I can share the, I believe I can share the my PowerPoint slide, right?
Yes. Yeah.
Okay. Can you see it well?
Yes, it is. Yeah, it's clear. Yeah.
Okay. So my name is, as you already know, MD Rafayet Alam. I am an associate professor at University of Tennessee at Chattanooga. Good morning, you all, in this presentation. It's my honor to present this in front of you. Now, a disclaimer, this is mainly focusing for the new researchers or the students who have just started doing their research, not for those who are already experienced researchers. So, and I will try to keep it in time, but if I cross your time, feel free to stop me. Then I can go to question answer things. And for me, I have no problem even during my presentation if you stop me and ask for any clarification. But I mean, I don't know what is the procedure, but I personally have no problem if I'm stopped during my presentation, okay? For any clarification or if you have any question. Okay, so the outline of my presentation, as I will first talk about the descriptive statistics, then selecting the empirical model, and then I will briefly talk about analysis of two types of data. One is panel data, the other is time series data. Now, for any paper, any good paper, introducing the paper with good descriptive statistics is important for various reasons. So I have listed a few reasons here. First of all, for you yourself to check if the data you are using in your empirical research are correct or not. For example, I have listed an example here. So if you find the mean, then minimum and maximum of, say, age data of a sample, and if you find the maximum age is 500, that means someone is 500-year old, which is not definitely possible. So that means this 500 is an incorrect data point. Now, you know there are some incorrect or erroneous data in your sample. You need to correct them. So listing these descriptive statistics at the very beginning of a paper give you and give the reviewers the impression that the data you are using are correct. Then there are various sources of error in data. One is printing mistakes, like they're supposed to probably, it was supposed to probably 50 years. So there should be a point before the last zero, but mistakenly the point was not there, makes it 500. So it's a printing mistakes. Coding, decoding, if some of you use Stata, when you use Stata for decoded data or something, the decoded data may be completely different one than what it shows originally. Then definitely there is always mistakes in data collection. If it is a survey data or something like that, people always make mistake there, and you have to, sometimes the burden is on you, the researcher, to correct the data and use the corrected data. Then sometimes there is mismatches in units. So for example, the age is in years, but for example, someone collected this one in months, so it is actually 500 months. So whereas these are year this is month. So in a series, the units cannot be 2, it has to be 1 unit. So you have to make sure that the single unit is used. Then definitely if you use survey data or data collected from field, there is a good possibility that there will be a lot of missing data there. Now, there are a number of ways, scientific ways to deal with missing data, and you have to follow those scientific acceptable ways to deal with missing data. You cannot just do something which is not acceptable to deal with the missing data. That will hurt your paper. So any data error should be addressed seriously and corrected properly before you proceed on, and you have to convince the referee that the data you are using are correct. Then another purpose of for using the descriptive statistics is to motivate your study. Now, it has been taken from one of my papers. There are probably 3 lines. One shows the energy price, another shows the metal price, and the other shows the food and beverage prices. Now, the fundamental determinants of these 3 commodities are different, and the prices of these 3 commodities should not move together. But what you see here is that the prices of the 3 commodities are moving together. So that means there may be or must be some underlying driver which is moving all of them together, or which is causing this co-movement. Then your research question is, which is that underlying driver? So that's your research question. You have motivated using this descriptive graph or descriptive statistics. Then another type of descriptive statistics is just comparing the mean between 2 groups. Say if you're interested in seeing if there is any discrimination in wage between males and females, just plot the mean, or just do some simple what is this called? Mean comparison hypothesis tests. Like a null hypothesis could be there is no difference in mean wages between male and female, and there is a difference in wages between male and female, and you can just test this simple t-test, and say you found that yes, there is the wage of the males are higher than the wage of the females. Now, it doesn't necessarily mean there is a discrimination in wages between males and females, but it has motivated your study that there may be a discrimination in wages between males and females, which may have, or which has motivated you to further test it using regression and controlling other controls. So this is the motivation to check if there is a discrimination in wages. Okay. Then so everything is all right? You guys can hear me, right? Yeah, okay. Sometimes in Zoom, I keep going, and later on I discover that nobody heard anything. I hope it's not happening. Okay.
Yeah, we can hear you. Yeah.
Okay, thank you. Thank you for confirming. Okay. Another important reason for using descriptive statistics by plotting the variables, so the distributions of the variables, especially the distribution of the dependent variables, to understand the nature of the variables, so at least dependent variables, whether the dependent variable is continuous or it is count data, or the dependent variable is dichotomous, like passed, failed, something like that. You can, if you want, you can draw the probability density functions, like, or histogram, etc. And this descriptive statistics of drawing the distribution of the dependent variable is important, because the distribution of the error term depends on the distribution of the dependent variable. So if your dependent variable is continuous, you should choose one type of estimation technique. If your dependent variable is count data, say from 1 to 9, you should choose a different type of estimation technique. If your dependent variable is dichotomous, just like say pass, fail, these or that, you should choose another type of econometric model. So understanding the distribution of at least the dependent variable before you move on is important to justify the econometric method, OLS, or some other method you have chosen to justify those methods. Excuse me. Then again, if especially it's true for the time series data, they usually have trends, also seasonality, cyclic behavior. So with the descriptive statistics or some descriptive graphs, you can show the kind of trend or seasonality or other properties your time series data have, and accordingly you are addressing those issues before you putting your data in the estimation. Excuse me. Then definitely before you move on, the sample period you have chosen in the time series, especially if it is, or even in the panel data, that has to have a good justification or explanation that why have you chosen this sample period, whether the data beyond this sample period is not available, or there are some issues in the series that why you didn't include those periods. But there should be some sound explanations of the sample period chosen for your estimation. Now, selecting the empirical model. Selecting the empirical model is very important. It cannot be simply cherry-picked, and the referee has to be convinced about the empirical model. So one cannot simply select a model from nowhere. Like you cannot simply say that I am testing the impact of gender on wage. So on the left hand side is wage, and on the right hand side I have just chosen a few variables of my whatever I wanted or of my wish. No, you cannot do it like that. So you cannot just pick the right hand side variables from as you wish. There has to be some motivation for that. As I said, one cannot simply cherry pick the explanative variables as well. So the empirical model must have enough credibility and must be econometrically correct. So if the empirical model lacks credibility, that if the referee thinks that it didn't include sufficient or important right-hand side variables, or the referee think the model is not econometrically correct, say you are supposed to use logit model but you use OLS to estimate it, then it is very likely that the paper will be not get through because this is a serious issue. Now there are a few ways to select the empirical model. One is based on theoretical underpinning, either based on the logical conclusion or mathematical model building. Now, the logical conclusion means that you have ample idea, or you're almost an expert in a field, then you have discussed all the issues, and then you have reached a conclusion that remittance positively impact economic growth. So that's neither based on any mathematical model nor based on any prior empirical work. It's just your knowledge in remittance, in your economy and everything. So you have applied all your knowledge, you logically analyze those things and then reached this decision that remittance positively impact economic growth. And then you have motivated your model or paper, and then you have gone for testing your empirical model. Now, one thing, if you are a Nobel laureate, people will believe whatever you say. But it is very difficult to convince people empirical model simply based on your knowledge in that, or based on some logical conclusion. And it is also difficult for the beginners or the new researchers who are not experienced in the economy or in an issue. So I don't see much prospect, especially for the beginners or the new researchers, to motivate empirical model based on logical conclusion. That will raise a lot of questions and confusions among the referees. So that's not a viable path for at least for the new researchers. The second one is mathematical modeling. So first of all, you must be familiar with the advanced mathematical modeling techniques. Like if you do macro, you should be familiar with dynamic stochastic general equilibrium model, DSG model, or real business cycle RBSE models, how to solve them. And second, you cannot solve this by hand, unfortunately. These are too complicated to solve by hand. You have to take the advantage of the programming skill in programming softwares like MATLAB or Mathematica, or there are some other softwares. So to solve a sufficiently complicated mathematical model to motivate your empirical work requires two skills. Number one, your skill in mathematical modeling, that you have to be very comfortable with DSG and RBSE at the advanced level, as well as you have to be comfortable in the programming skill in mathematical MATLAB. So if you have these skills, then you can go for theoretical mathematical model solving, and say the model which is sufficiently complicated you solved is predicting that the remittance positively impact economic growth. Then you can motivate your empirical model based on this mathematical finding. But if you're not very good at the mathematical modeling and or in programming those things in the softwares, then this may not be also a very viable path to motivate your empirical work. Now, the second one is based on prior empirical work, which is much easier. And I always recommend these to the new researchers or beginners to follow this. There are a lot of advantages of following this method, which is following a prior good empirical work. Now, as I said, this is a relatively easy technique, motivating the empirical model based on prior empirical work. So what all you need to do is select a good recent paper. By recent means try to get it in like 2, 3, 4 years. I mean, the more recent, the better. And a paper published in a good journal, read the paper carefully and see if you understand, especially the empirical model they used, and then see if you can do it with the skill you have. Like if you know Stata, if you know how to do panel data estimation, see if you can, like 80-90% if you can do it. Now, if you think you understand the empirical model reasonably well, and you think that, okay, you can handle it or you can do it, okay, read the paper carefully. Then try to find out a few other relevant good papers which are relevant to this paper. Read them and try to understand the literature, especially the trend in the literature. Research is a building block. You are building one brick on another. It's not just randomly picked from somewhere else. So if you understand the trend, that will help you understand that which brick now you need to put on top of that things. Now, if you understand that, that will be very helpful for you. You can show your understanding and your insights to the referees. But if you even don't understand the trend very well, that may also work. I mean, sometimes it requires a lot of reading and time to understand the real trend in the work. So if you think you really don't know much, don't worry, that may also work. Then after reading those other few papers, go back to your original article, the one you chose to extend and replicate. And then see how you can extend it or contribute on top of what that found. There are a number of ways to extend an existing paper. One way is econometric improvement. So if you say the paper applied an econometric technique and you think you know a better econometric technique, then you can apply that better econometric technique to see if the results hold or not. But for this, I mean, you have to also know better econometrics than the one applied in that good journal. The second one is testing on another set of countries. This is a very common, I mean, it's a very common practice in the PhD classes and things like somebody did something on developed countries. Now you chose the developing countries to apply the same model on them. So this is a common practice, an easy thing, but to publish this type of paper, you have to have enough justification for why it makes sense to apply the same model on a set of developing countries. So you have to explain clearly. You have to the rationale or the justification for applying the same model which was initially applied on the developed countries. That's why you are now applying it on the developing countries. You have to sufficiently explain the justification for that. Simply they did it for the developed countries and you took the same model and applied on the developing countries. With that, I mean, justification will have a tough time with the reviewers. Equally, this is also common practice of extending an existing paper in terms of time. So say an existing paper looked at until that time period of 2015 or 2016. Now you are thinking that there has been a lot of changes after that in the world. So you'd like to extend the same model until 2022 and see if the results hold or not. Again, why you are extending the time period? You have to give a very good justification for that. Without any justification, just extending the time period of an existing paper will not have a good time with the reviewers. So if you want to do this type of practice, give a good justification for extension. Another good way, which one I like most, of extending his paper is finding a caveat in the model or shortcomings in the model. There could be a lot of shortcomings in the model used in the original paper. One shortcomings could be they probably tested using a linear model. Now you think the relationship is not necessarily linear, it's non-linear. Say if oil price, say they showed if oil price increases, say inflation increases. Fine. Now you can say if oil price increases 1%, inflation increases 2%. Now if oil price decreases 1%, that may not necessarily mean inflation will decrease by 2%. Now you want to check it. It's a good addition, good contribution, a non-linear test. Now, say they didn't include any, what is that called, quartile or some non-linearity in the things. You believe the relationship between oil price and inflation is not necessarily linear. after some point, maybe oil price does not contribute much to the inflation or may contribute more to the inflation. If you have such kind of thinking in your mind, you can include a quartile term in that equation. So so there are a number of non-linearity things and asymmetry things in the model. If you read the papers, you will come up with. So those are now a very sellable things people apply because they choose papers who apply symmetry or linear model. Now they apply, other people try to apply non-linearity and asymmetry and publishing in good journal, showing different results. Now another way could go further, deeper into the things. Like say somebody said that okay, oil price increases the inflation. Right? Now you can argue that okay, oil price may increase because of a shortage of supply of oil or because of because of increase in demand for oil. Now you can argue that okay, if it is the increase in demand for oil that increases the oil price, that may increase inflation. But if it is the increase in oil price because of the shortage of oil, that may not necessarily increase the inflation. So what you can do, whereas the previous paper took only the oil price, you can take two underlying shocks here of oil price increase or underlying drivers of oil price increase. One is from supply side and the other is from demand side. And if you can show, okay, the supply side one does not contribute to the inflation, but the demand side one contributes to the inflation, it's a very good contribution, good addition to the things. So there are a number of ways of doing that. I mean, if you read the papers, we'll come up with it, but this is a very effective way of extending an existing paper, I can tell you. Now, another way, changing the definition of variables assumptions. Like say someone used nominal GDP, you can say, okay, let's try real GDP. Someone used one type of definition of inequality, you say, okay, I'm trying another type of definition of inequality and see if things hold or not, or assumptions, you can change those things and can add the things. Now I should say second module, let's say, or section, whatever it is. So this is the panel data models. Those of you who have taken econometrics, or at least the second course of econometrics, may have some familiarity or with these things. So panel data models means you have both time dimension and the cross-section dimension, and very rich model. By the way, there is the first one, the cross-section models. There are also a number of papers written using cross-section models, but the papers written, if I know correctly, using panel data models and time series models are probably more than the papers written using cross-section data. But anyway, that is also important, but for the sake of time, I'm not talking about the cross-section data. So there are a few types of panel data models. The most common one is most probably the two-way fixed effect model, where you run a dependent variable on a set of explanatory variables, and as well as you control for the cross-section fixed effect and the time fixed effect. That is called two-way fixed effect model. I have selected this model from one of my papers. It has not yet been published, but I mean, yeah, there it is. Now, the panel data model, the things to remember, there are a lot of things to remember, but just to mention a few. Always it is better if you understand the underlying econometrics. The better you will know the econometrics, the more confident you will be in your econometric model. There is no substitute for knowing econometrics well. So if your professors push you hard to learn the econometric theory and derivations and mathematics, even if they are not sometimes interesting, do them honestly. Believe me, at some point, especially if you want to pursue a career in research or academia, your good knowledge in econometrics will help you a lot. There are a number of good books On panel data econometrics, I believe one of them I like is by Greeny, Econometrics by Greeny, probably because I studied that one, but there are, again, should be there a number of other good books also on panel data econometrics. Second, you have to be aware of the distribution of the dependent variable. By the way, any question? Can you see well my slides?
Yes, we can see the slide. Yes.
And I hope you can also hear me. Okay, thank you.
Yeah.
Second, you have to be aware of the distribution of the dependent variable, as I already touched it, that whether your dependent variable is a binary, follows binary distribution. If it follows binary distribution, you have to choose logistic model. If your dependent variable is a count data, you have to choose Poisson distribution. If it is continuous, you can choose normal distribution. Now you have to be very careful because the softwares cannot as such recognize the distribution of a dependent variable. Say your dependent variable is a binary distribution, yes, no type, pass, fail type, two values distribution. And you command or write the code in the software to run the OLS. Software will very confidently run the OLS and will get you the results, but that will definitely a wrong result because you are the one who was supposed to tell the software that run the logistic model, not the OLS model. So if you mistakenly order the software to run the OLS on a binary distribution, software will do that, but definitely you will get wrong result. So to let the software know that what exactly the code or command the software should run, you have to first know by yourself that what is the dependent variable and what model, econometric model you should choose to run on such dependent variable. So that's important. Again, I'm saying it again and again. The right-hand side explanatory variables have to be very well grounded. You cannot simply cherry pick. So I review on average 2 papers in a month. Many of those papers I see that the people choose the right-hand side variables without any justifications, probably based on what get them good results or something like that. But that doesn't help the author. So you cannot simply cherry pick the right-hand side variables. It has to be either logically motivated or motivated through a mathematically solved model or motivated through a previous good empirical work. You can't omit any important explanatory variable, definitely. I mean, that will hurt your paper. You have to be very careful about the units of the variables. Like if it is percent, you should not take log of it. If it is dummy, you should not take log of it. So you have to be very careful when you are choosing the units of the right-hand side variables. Then the interpretations of the coefficients have to be correct as well. If it is both dependent, independent, and in logarithmic form, or one is in log, the other is in linear form, or one is dummy, the other is continuous. You have to be careful when you are explaining the coefficients. So consult a good econometrics book. All the textbooks should have the interpretation of the coefficients. So read good econometrics books to learn the correct interpretations of the coefficients. The functional relationship has to be correct. Now, before I proceed on, probably I should have clarified about like how, based on an empirical model, you should choose a model. So if you have, say, in an American Economic Review, so they run a model, empirical model, just choose exactly that model and then add your addition. Like add, if you think they missed an important variable, add that with justification. If you think they didn't take care of linearity in their model, on that model, put your non-linearity. If you think they didn't take care of asymmetry in their model, on their model, put your asymmetry, and then write clearly in a paper that I am following that model published in that paper, and I'm doing my work on top of that. So that will remove a lot of hesitation and doubt from the referee's mind that you have not cherry-picked this model. So it is always a good idea to refer your empirical model to some good paper published in a good journal, so that the referee will be ensured that you haven't cherry-picked these right-hand side variables. So once you chose that established model from a good paper, then add your things on it, whether new variables, whether nonlinear term or asymmetry, and clearly mentioning that I am working on that model, and add your things with clear justification. That will remove a lot of doubts and confusions from the reviewers and referees' mind about your econometric model. And that, I should say, will do half of your work in the paper. If the econometric model is correct, it is very hard to reject the paper unless it doesn't have any contribution at all. But it is very easy to reject a paper, no matter what the paper is on, if there is any doubt on the econometric model. So always referring the econometric model to an established model used in a good paper, in a good journal, is always safe and wise. I think I'm clear. Yeah, okay. The number 7, the functional relationship has to be correct. If there is a strong theoretical reason of nonlinear relationship between dependent variable and any of the explanatory variables, you should consider that in your empirical model. And then again, you probably know from your econometrics classes that in panel data model, in most of the cases, there are the problem of heteroscedasticity and serial correlation, and you should take care of them. One good way of taking care of them is clustering the errors in the cross-section units. I think in Stata it is cluster something, maybe. Yeah, I forgot. Anyway. Then one very common problem that all the referees and all the audience, when you are presenting a panel data model to a conference or somewhere, will raise is the endogeneity problem. So what the endogeneity problem? People may think it is not necessarily the independent variable is causing the dependent variable. It's simply a correlation between them, or even the odds, it is the dependent variable which is actually causing the independent variable, not the other way around. Now, it's a common question you will face for any paper with panel data you send to any journal or present in a conference, and you have to take care of it. So there are a number of ways of taking care of it. One way is logical, or you can use simple statistical things to avoid these things or to take care of endogeneity. The logical is like, say, simply you can use logic that it doesn't really make any sense that the dependent variable is causing the independent variable. For example, the sales usually goes up before any festival, whether it is Eid or whether it is Christmas. Now, you can put the left-hand side variable or dependent variable as the sales and put the festival seasons in the right and see that, okay, during the festival, sales goes up. Now, it doesn't make any sense that sales on the right-hand side and this festival in the left-hand side, that whether if sales goes up, the festival comes. No, the festival doesn't depend on sales. Whether there is sale or not, when there is the date of festival, the festival will take place in that date, right? So you can argue that it doesn't make any sense to say that there is a reverse causality that the sales is causing the festival. So logically, it doesn't make any sense. So there's no endogeneity issue. You can safely say, I'm putting the sales on the left-hand side and the festival on the right-hand side, and it is completely free from endogeneity because the reverse causality doesn't make any sense. Or another simple statistical technique is to use the lag of the independent variable, right-hand side variable. So the idea is how come today's variable may affect yesterday's variable. So if you want to avoid the question about the dependent variable affecting the independent variable. That is the reverse causality, I mean, which you do not expect, right? The dependent variable should not cause the independent variable. What you are trying to show is the independent variable is causing the dependent variable. Now, to avoid it, what you can do, you can use one leg of the independent variable to say that, okay, dependent variable is today's variable, independent variables is yesterday's variable. So how come today's variable caused the yesterday's variable? And you can avoid the question of endogeneity simply by using using the lag of the independent variables. Okay. Some other ways are try to find out natural instrument, try to find out an instrument to proxy your variable of interest, which has doubt about reverse causality or simple correlation. Now you can get the proxy in two ways, either naturally from the nature. For example, say you can use nighttime light of a city as a proxy for the economic development of that city. So that is a natural instrument you can pick. Now, when you are choosing an instrument, you have to make sure that this instrument is highly correlated with the variable for which you are using this proxy, but this proxy or instrument doesn't have much correlation with the dependent variable. So that's the idea. Like if you want to avoid GDP for some reason on the right hand side, you can use the nighttime light data. So the idea is if it is too much late, it's a developed country. If it is dark, it's not a developed country. So for growth, you can use that one. So that's a natural instrument, and which should have high correlation with the variable you are using for it, and but should not have high correlation with the dependent variable. So that's one way of getting the instruments naturally from nature. Sometimes it's difficult to get the instrument from nature. In that case, you can take the help of econometrics. We call them synthetic instrument, 2SLS, 3SLS. These are ways through econometric techniques you can get a instrument or proxy, and then you can use that instrument or proxy in your econometric model instead of the variable which is doubted have endogeneity with the dependent variable. Then you can use more complicated econometric models such as the one dynamic system GMM. They are supposed to have a built-in system within themselves to take care of endogeneity. And then also you can use some different econometric specifications, which also the people who use them believe they are free from or least affected by the endogeneity. Like one is stochastic frontier analysis. Then other models are also used in panel data, like difference in difference, hugely used in the impact evaluation dynamic models. If you use the lag of the dependent variables as one of the right-hand side variables, quantile regressions, like in addition to look at the effect on the mean value of the dependent variable, if you also want to look at in other points, if you want to look the effect at the other points of the dependent variables, the quantile regressions are now also popular. There are also some non-parametric models where you need not to be much worried about the distribution of the variables, like propensity score matching, regression discontinuity. These have some merits, some shortcomings, but I mean, these are used in development economics a lot. Now, when you write an empirical paper, empirical results are highly sensitive to a lot of things, to sample period, to number of countries included, to the techniques applied, to the definitions of variable used. So to convince the reviewer that your results hold for a number of different variations, you should show in your paper a good number of robustness checks using some things. So that's remember that when you are trying to sell an empirical paper, showing a number of robustness check is needed. Panel data analysis, Stata is a very good software for panel data analysis, unless you use some very specialized technique like propensity score, a stochastic frontier model or something. They have their own software, but in Stata you can do almost everything. So for panel data, so far I know, knowing Stata should be almost close to sufficient. Okay. Now, the time series econometrics, I will not discuss this in detail. I will just go over this. Now, time series could be univariate, only one variable. So, for example, you are trying to forecast tomorrow's GDP using today's GDP, or trying to forecast today's GDP by yesterday's GDP, something like that. I mean, time series is good. I mean, you can do it in time series. A convergence, basically like you need to type test that whether a variable is says poverty rate in is the poverty rate in Indonesia converging or not, something like that. Then especially in finance, it is popular to check the trend cyclic behavior of the series for something they do. So these basically the things you can do with single variable time series. Now, multivariable, where there are more than one variables, you can test causality, whether one variable caused another variable, whether remittance caused GDP growth, or prediction, whether money supply can predict anything or not. Forecasting, if you want to forecast if money supply can forecast GDP growth or something, or impulse responses, like if you give shock to one variable, what will be the movement of the other variables over time. So a lot of things you can do. Now, multivariate means more than one variable. You can either do it in a single equation setup, where there's only one equation. For example, autoregressive distributed leg model, error correction model, or co-integration model. Or you can use a system of equations where there are a number of equations in the system, 3, 4, 5, 6 equations, and these are very popular, like vector autoregression or vector error correction model. Now, vector autoregression is very useful technique to do a lot of time series analysis to predict or check the causality. Now, some improvement of the simple Var model is structural Var models. Christopher Sims first showed that. So the structural Var model is you are imposing some restrictions on some relationships between some variables based on economic logic to produce results which are driven by more economic underpinning. So that's the basic assumption. So that means if it is 4 variables, 4 system of equation, you are just telling the equation that, I mean, which should affect which one and which should not, and then run the model and then see what the reactions are. Now, there are a lot of ways to put those restrictions on the relationship between the variables. Could be 0 restrictions. You can put that, okay, I don't believe that money supply affect GDP, just put that coefficient 0. So when the model will be run, it will assume it is 0 and then will give you the other results. Sign restrictions, say you can believe the money supply can only increase the GDP, but never can decrease the GDP. So you just put the plus sign there. So the system or the software will take it always positive and then will give you the remaining results. Block exogeneity, like if you want to believe, like say you are testing a model which has US variables and the Indonesian variables, and if you believe the US variables may affect the Indonesian variables, but the Indonesian variable should not affect the US variable, so you can just block block or stop the Indonesian variables from affecting the US variables and then get how the results are. So these are basically some assumptions based on your economic understanding, putting in the relationships between the variables in a system of equation to get the ultimate results, which are believed to have economic base. Now, there are some richer models, richer in the sense that including a lot of variables or series, like say, you can say, for example, Indonesian inflation depends on what? Indonesian inflation may depends on 100 of variables. Now, it's not practically possible to input 100 variables in a model, whatever model it is. So what you can do, you can just get a factor. There are a lot of ways to get a factor. You can get a factor or underlying series or whatever you say from those 100 variables, and then take that factor and use in a model. So you can use that factor in a structural Var model also, so which will be like factor augmented structural Var model. So that's basically rich model in the sense that you are considering a large number of series. If you believe in Bayesian analysis, then Bayesian Var. There are again non-linear Var, like time-varying parameter Var or Monte Carlo Var or Markov switching Var, which are all non-linear Var. If you believe the relationship between the variables in the system are not necessarily linear. Now, in time series, using time series, especially in the finance, they also have a lot of interest in the volatility of the series in the markets. So to check the volatility of the financial time series, Arch model, Garch model, these are commonly used. There is another trend of factor analysis of principal component, as I said, to just to understand the underlying trend of number of series. People commonly do it. There is another trend now using connectedness, especially after the 2008 financial crisis. People try to understand how the systematic risk or risk in one market may spill over to another risk, another market. After a seminal work by Diebold and Ilmies, 2012, a number of papers now trying to see the connectedness between various markets to understand whether the markets are connected or not. So the reason is, if the markets are connected, you cannot diversify your risk simply investing in these two markets because they're connected. If they fall, both of them fall. If they rise, both of them will rise. If they're not connected, then okay, investing in both the markets, you may diversify the risk. So that's the underlying idea. It's called connectedness analysis. If you look at the finance journals, you'll see a good number of papers on that. Then state space models. These are basically the time varying parameter Var type model, where just we believe the value of the coefficient change over time depending on each space or a state. One could be Markov switching models. So if you have two states, so you'll get two coefficient, one coefficient for a volatile state, one coefficient for a less volatile state, or it could be like 3, 4, 5 states. So you will get 5 coefficients for 5 states rather than just getting one state. So this coefficients depends on the state rather than just one single throughout the period. Kalman filter type things, just to filter things from there. So this is a short overview of the time series, definitely not everything. If you wanna look at some books for applied time series econometrics, one very popular book is by Walter Anders, Applied Econometric Time Series. Another is by Diebold, Francis, the Time Series Econometrics. If you're really interested in structural Var, this kind of things, to analyze the monetary policy shocks or fiscal policy shocks, the third one by Kuliah and Helmut, Structural Vector Risk Analysis, should also be a good book. But definitely there are many other good books there, but I mean, I just mentioned here because probably I'm familiar with these things. For time series analysis, R is a very good software. It's free. Good to learn. MATLAB, not free, but again, a very good software to learn. And if you really, Python is slightly programming based, so language based. So if you think you have good command on this language or programming, Python could also be a very good software to learn, especially those who are now young student, just learning, just studying. This is a good investment to invest your time in these softwares, learning in these softwares. They will help you on your way, believe me. Yeah, thank you. Thank you very much. I don't know exactly how much time I have taken, but hopefully I haven't taken too much time. Now, if you have any question, I'll be, I mean, if there's time and if you want, if there's any question, I'll be more than happy to address those.
Okay, thank you, Professor Rafayet. And yeah, so you are just in time for the presentation of the material. And now we are going to we still have like 15 minutes for the question and answer. So if any of the participants have some question, you can type in the chat. It can be in Indonesian and I will have to translate it. Otherwise, you can also directly ask to Professor Rafayet. All right. Okay, so before this question from the participant, well, you cover almost all of the topics that we cover in the Econometrics 1 and 2. Actually, the some of the part that you present is like in the advanced level that we actually do not cover in the undergraduate, but in this occasion, there are also some postgraduate student as well joining in this guest lecture. Any question from the participants? Okay, but now there are some questions that I would like to ask from your presentation, Prof. Rafayet, particularly related to the analyzing the data error. In the beginning, you talk related to the descriptive statistic, the importance of identifying the data error. And many of these undergraduate students in our department, they have to write a final project, paper project, as a requirement for the graduation. And many of them still finding like ignoring this type of step of identifying the data error. And you show that if there are like very extreme example, like in your example, it's very extreme. The age is like 500 years, but it is not logical. But there is some subtle error that it is a little bit more tricky to identify. So do you have any suggestion on that case?
So that's called elimination of extreme values. So what some researchers do, they get rid of the say lowest 2% of the values and top 2% of the values. So they think those values are whether error or not error, do not really represent the whole sample, maybe for some reason. Say it's a price data. So probably one day the price of one bottle of water, someday for some reason, say $10. But anyway, that may happen in 1 day or 2 days for whatever reason, but that doesn't really represent the price of the bottle of water. So what some researchers do, they simply get rid of the lowest 2% of data and the top 2% of data. So that through that, they expect that all these extreme values, unusual values are take out from the analysis. So there's one good way. And some other issues arises when there is missing data. So handling the missing data is slightly tricky. So I would suggest, like, say, if you run a panel data, Stata can handle missing data. So if the software can handle missing data, and if there are not too many missing that you do not have sufficient sample So I would suggest leave the missing data as they are. Don't try to interpolate or put any value through anything on that. Say it's a panel data, say you have say 2000 sample point, you're supposed to have 200 data are missing. So Stata can handle missing data. It will not consider that one when it is analyzing. So rather than filling in those missing data with some number through whatever way you wanna get it, I prefer just leaving them as missing there. Just that would be nice. I mean, yeah. So these are some techniques I apply. Luckily, I mostly work on time series data. So time series data are much cleaner than the cross section or panel data. So because most of them come from like central banks and things. So if there is any missing data or an extreme value, they usually have already taken care of that. So when we get the data, most of the time is very clean data.
Okay. One of the questions that I often got from the student related to time series is how many data points should be included, the minimum. So it can be, we can use it for the time series analysis.
So time series analysis are very sensitive to the number of data points, the length of the time series. Like usually it is said if it is co-integration or error correction, at least 200 data points is required at least. Now, having said that, when you are trying to, so if it is yearly data, most of the countries in the world do not have 200 years of data annually.
Yeah.
So that's a caveat in those type of analysis, like co-integration or error correction model or some other time series analysis that we are. So that's one thing. Second, even if you have a long time series, you have to be careful if there is any break in that series. Like say you are taking stock price data. So stock price data are usually available daily. So you can probably take 2000 data point or at least 3000 data point. Now say you can go back to say daily data back to say 1970. Now, if there is a break in 1982 or 1983, you should be careful about that. I mean, either you should do something in your model to take care of those breaks, or if you already have sufficient data, simply do not go beyond 1982 or something like that. Or to the least, run two more models, one with data before 1982 and one with data after 1982. So there are two things. Number one, you have to have sufficient data point. So there's this, unfortunately, it is what it is. You need 200 at least data point for those co-integration, error correction, estimation to be viable. And second, in time series, the structural breaks are very important. So whatever series you take, stock market or thing, you have to be very careful about those.
Right. Still about the time series, there are some students who are asked whether, because the data is only available in the annual frequency, and then they try to make the interpolation of the data. For example, from the annual data, they interpolate into quarterly data, so they can get more data points from that. Is that okay, or is there any issues on that?
It is okay the other way around. Like it is not uncommon to average the daily data to get the weekly, or to average the monthly data to get the annual data. So from the other side. But when you just divide the annual data by 4 to get quarterly data, so the annual data, say the annual data is 100. Now, if it is divided by 4 to get the quarterly data, for each quarter you are getting 25, right? So there will be huge persistence in the data, like 25, 25, 25, 25. Then probably 26, 26, 26, 26. So this type of persistence is very is not helpful in time series analysis. So this is not a common practice to divide the annual data into the smaller units because of persistence. But it is somehow common to make the smaller data into a bigger units, like taking the daily data to make monthly data. So you just, if you have daily data, take the 30 days data, add them, divide by 30, the value you get, put it for that month. It's a common practice.
Right.
So there is a question in the message.
Yeah.
So
Right.
I would like to ask about the panel data, which dependent variable is stationary at level. Independent variable is stationary at the first difference. How can I? Okay, unless you are running a panel VAR model, you don't need to be worried about the stationarity of the variables. As such, the panel data, we use the yearly control and or whatever time series is your, we use the control for that in addition to the cross section control. So that control should take care of a lot of the non-stationarity between them. So the easy question to answer is, unless it is a panel VAR, if you're not running a panel VAR, it is the common panel model we run, people run, you can usually see two-way fixed effect or something like that. You don't need to worry about or test for any kind of stationarity of the variables. But if it is a panel VAR model, then of course you have to check for the, probably you have to check for the stationarity. Now, if I assume it is a panel VAR, and then if your question is, I would like to ask about panel data which dependent variable is stationary at the level, but independent variables are stationary at the first difference. Okay, so this is slightly tricky and a practical problem. The some series are stationary at level, some series are stationary at first difference. What should one do? So what I do, I take first difference of all of them. So that's the easy solution. It may not be the best solution, because taking first difference always costs some information. I mean, GDP and the growth of GDP are not the same thing. Income and the growth rate of income are not the same thing. So whenever you take difference for whatever reason, that has some cost. But if you have some variables stationary in the level, some stationary at the first difference, some maybe stationary at the second difference, just take, I mean, one first difference or something like that. I mean, that should be fine. That should be fine.
Okay. Right. Is there any other question from the attendants here? Right. Well, we are almost at the end of the schedule for this guest lecture. So I'm not sure what time there, but this in Indonesia is okay. There's another question.
How to determine this natural instrument? How to find natural instrument? Once I read a paper, use rainfall as instrument for health outcome. Suppose in the same model, and we want to use other instruments such as disaster. How to find out which instrument is better in the model? So, I mean, as I said, I mean, if you choose a natural instrument or proxy, it has to have a very high correlation with the variable for which you are using the proxy. Now, how you will understand that it has a high proxy? It could be a common sense, like the way they use the nighttime light data for development, or you may check for the correlation or other kind of correlation test to see if the proxy has good correlation with the variable you are using this proxy for. At the same time, usually it is a common sense that the proxy doesn't have much relationship with the dependent variable. That's why you are choosing this one as a proxy, right? I mean, because it doesn't have much relation with the dependent variable. So these rainfall data or this nighttime light data, these are commonly used in the development literature. So you probably would like to read a few of the development papers to understand their motivation of how they are motivating these natural proxies to use as a proxy for some of those things. Yeah, that's, I mean, my answer, but I think most of the time it is like a common sense analysis, something like that.
Okay. Well, we are at the end of our guest lecture today, because the schedule is we are finishing at 10:30 a.m. here, Indonesian time. Okay, so thank you, Professor Rafayet, and for your insightful presentation. You are covering lots of topics there, and I hope all of the participants will learn from your presentation. Okay, thanks again. And if you have any last thing that you would like to say to the participants.
No, I don't have. Thank you very much again for inviting me. It's an honor for me, and I wish you all the success. Thank you. Thank you very much.
Thank you. Thank you. Okay,
I'm
so
leaving now.
okay, thank you. I will give it back to the master ceremony. We have some closing. Just a minute.
Okay.
Okay. Thank you.
Okay, thank you, Mr. Awalin, and thank you, Prof. Rafayet, for your great and insightful presentation. And thank you, Pak Alin, for moderating our guest lecture today. I hope all participants learned valuable lessons today, but for all participants, don't forget to fill the attendance link that the committee share on the chat box. And thank you everyone for still joining the guest lecture. That is all for today. Wassalamualaikum warahmatullahi wabarakatuh. Have a good day. Thank you.
Thank you. Okay, thank you,
Thank you.
bro.
Thank you.
So